Hello, everybody. How are y'all doing this evening? Mute. There we go. I just got back from vacation. And while I was on vacation, I got an order from a client. And I figured on gcm-1.com. And I figured we would hang out tonight and put that order together. I haven't put anything up on my channel in a while. And I figured, yeah, let's just hang out and live stream. So I went and I looked up that order. There were both build-it-yourself kits. So I can't build them, but that's okay. So we'll just build something else. And we'll consider this a hangout and soldering instruction stream or something like that. Why the heck not? So who all do we have here? Let's see who YouTube actually decided to notify to come and hang out tonight. We got John Mounts. Hi. Warm with the CRT and the soldering iron. Yes, 390 degrees, man. Garth. Hi, wave hands. Lucas Notch, good evening. Eric Miller, yo, how we all doing? So yeah, we're just gonna hang out, and I'm going to assemble a couple different things. Acid Rain is there. Sorcerer Stan, how you doing? The kits that this gentleman ordered from my website were the NeitherNet kit, which, you know, is a pretty straightforward kit, nice and easy to make. And so I figured we'll just go ahead and make one of those while we're at it. Why not? And the other kit was the Soft Card 3, which is my Soft Card 3 reproduction for the Apple III computers. That takes like 2 hours to build. I figured that would also be a really cool thing to do. But since he ordered the do-it-yourself kit, I guess I could put one together, but that takes a really, really long time. We'll see. I'm thinking that I'm going to put together actually one of my keyboard encoders instead, because those are really cool kits to put together. Lucas Notch had a very bad day. I'm still traumatized from watching Squid Game. Don't get why young adults these days like such stuff. Yeah, I heard that that's a thing. I saw there were memes about it. I'm not going to watch it. So, yeah. What about everybody else out there? What do you all think about Squid Game? You can leave your discussion in the comments about that. So let's see, what are we going to put together tonight? Yes, we were going to do an Ethernet kit. So to do that, I need to get some party parts over here to build one of those, and we can switch over to the camera to the side, to the bench cam here to do that. So for Ethernet, all my Ethernet stuff is in this one box. I need a PCB. I'm going to need a couple of these Ethernet jacks. If you're all curious what NeitherNet is, it's my take on phone net adapters. I basically redesigned the phone net adapter using a schematic I found from back in 1991 or something, and I adapted it for this purpose. We need a cable connector doodle, and we need a whole bunch of resistors. And I also need capacitors. I can also use this as a reference for the wiring color code. This goes in here like that. Now, other stuff that I need is I also need some capacitors, which are up here. Let me grab those. 100 nanofarad capacitors is what I need. I think I need 2 or 4 of those. I need 2, exactly 2. Cool. Now we can get to putting this thing together. I also need a little piece of wire, which I've got a spool of wire down here for exactly that purpose. Big, heavy spool of wire. That is my 6 conductor wire. 1, 2, 3, 4, 5, 6. Yes. So we need 6 conductor wire. NeitherNet is used to capture the Neither bunny. Haha! Jokes. Yes, like I said, I just got back from vacation. Very interesting vacation. I was much nearer to VCF East than I've ever been before, but not quite near enough to justify driving up to New Jersey from where I was staying in Maryland. So I couldn't make it to VCF East. However, because I was in Maryland and only about a half hour from the System Source Museum, I went there instead. I got a lot of footage, a lot of B-roll from there. So I might throw together a vacation B-roll video or something from while I was there. Not sure yet. But yeah, I basically took a week off to just hang out and do a whole bunch of flipping nothing because work has been absolutely crazy. For those not in the know, I work in effectively, I'm a sales engineer for a managed services provider. People hire us to, how can I put it? Manage their network so they don't have to have internal IT. And we focus on small businesses so that we're not putting any IT people out of a job. We have a really nice niche where we're helping small businesses, but also not unemploying anybody. And it's been absolutely crazy. I have local competition that's gone out of business lately. Everybody wants everything yesterday. I don't know what's going on. I have a lot of projects where we're shifting a lot of people to cloud, to our hosted cloud services and stuff, and it's just been a nightmare. So I had to take a few days off. DevOps is something I'm looking at. Yes, DevOps is cool stuff. Not particularly what I do personally. I'm kind of a weird jack of all trades. I know a little bit about everything, so I can kind of do all of the things, but whatever. Let's switch to the bench cam so that we can go ahead and put this NeitherNet adapter together. Let me click some buttons. I believe it is that. I think that's correct. Yes. And then we'll move the bench cam so you guys can all see me. There we are. I hope everybody can hear me okay. Can vouch for you. Your circuit design works wonderfully. Thank you, Eric. It does just kind of work. It's beginning to look a lot like Christmas. Are we talking about... I'm not sure what that's supposed to mean, but okay. I'll take it. Let's adjust the camera down a little bit better so you can see a little bit better what I'm doing. I'm not sure how well this is going to kind of show up here, but yeah. Do we want to do this? Let me see if do we want to do this in the microscope instead? I'm not sure, because in the microscope it's almost too close. Yeah, like that would be hard to see what we're doing, wouldn't it? Yeah, you can kind of see it, but kind of not. Yeah, that's kind of too close. Those wires look like Christmas decorations. Yes! I'll take it. Yeah, let's go back to the bench cam. Let's do that. And see if we can get a better angle, better focus, better something here. As you can say, this is just a really quick impromptu live stream. I have literally no plans or anything to happen tonight. I'm just hanging out. I wanted to share some time with folks and just kind of veg out after returning today to work to the craziness. So we're putting together the NeitherNet adapter. Basically it's the PCB. Got a couple of 1K resistors that go right here. Can you guys even see what I'm looking at? A couple 1K resistors that go there. A couple 10K resistors go there. A couple capacitors there that are used for isolation. Now the original phone net adapter uses proper, what are they called? Isolation transformers, but those are insanely expensive, whatever. And then I've got the actual Ethernet connected doodles there. This part is all the easy part, putting that stuff in. What's hard is doing the wire cabling. Doing the wiring on this side is actually not too bad, but putting the wiring on this thing, on this adapter doodle that plugs into the actual Mac itself, is kind of a pain in the patoot. So if you're going to order one of these kits for yourself, keep that in mind. That stuff is super duper tiny. Are you going to focus? Are you going to focus on what I'm doing, or are you just going to be dumb? There we go. So those are super tiny to get stuff into. Which this I usually use are you going to focus? There you go. I usually use what is this thing? Microscope for that. So if you ever purchase one of these as well, and you're wondering, well, why does he charge so much to assemble one? Well, you're going to see what all it takes to assemble one. Luckily, this doesn't take that long, so it's not that expensive. Retro Tech Chris, how you doing, sir? How are you? I believe you were at VCF, weren't you? VCF East? I missed you. I was really close to there, but I couldn't make it for reasons. So let's get our solder out here and put this thing together. Justin! Garth! Garth is asking a question. Which phone are you using there? Phone, you talking about this here? Are you talking my cell phone or what? Which phone are you talking about? Because that's going to determine the answer to that question. Yeah, just back from VCF East. Yeah, you see, everybody was at VCF East, and now all the people I know and everything, and I was that close. I was about 3 hours away, but I couldn't justify spending 6 hours of travel to go hang out for a day. It didn't, it was circumstances worked against me. So I'm sorry I missed y'all. The phone camera. This phone camera right here is I don't know. I don't remember what it is. It's an iPhone of some description. It is a spare iPhone. Every time I upgrade my iPhone, like this is a 10R, which I'll probably be getting a 13 here soon. Every time I upgrade that, my old phone becomes a spare camera. I think this is like a 10 or 11 or something like that. I don't remember exactly. The software I'm using is called DroidCam because it allows me to easily stream over the network to my PC. Yes, blasphemy. I use a PC for all my actual work. And it works well for me for my setup. So go ahead and get this soldered in place here. Doobie-doobie-doo. There we are. Okay, make sure that that's even. So we solder the 2 points on there to make sure they're in place, and then we make sure that it's all even on the side there before we continue soldering the rest of the connections for that. There's 8 of them, even though we're only really using two of the wires. It may seem like overkill, of course, but again, I wanted to use Ethernet for my NeitherNet solution for my phone net replacement because Ethernet cables are really easy to get compared to old phone wires these days. I mean, who has phones anymore, you know? Justin Morgan, I want to be at VCF East next year. Yeah, hopefully we can all meet up next year. Hopefully I can have everything lined up in my life schedule to be able to justify to do that. This year I had to, I was going to go to VCF Midwest, which is not the same VCF as VCF East. But I wanted to go to VCF Midwest, VCF East, Handy Assembly. I wanted to do all those things, but I have some folks in my life that are extremely susceptible to COVID. Up there, and the video is demonetized. They're susceptible to that because of their own circumstances, despite being vaccinated. And the past 3 or 4 weeks, I've been checking in on them because they've been alone, for lack of a better way to put it. I was helping watch them to make sure they were okay while they didn't have anybody to watch them for a few weeks. And so just the timing coincided with that. So I couldn't really go anywhere during that period of time because even, like I'm fully vaccinated. If I catch COVID, I'm going to get a kind of a nasty cold, right? It's highly unlikely anything bad's going to happen to me. But this person I was watching is so susceptible that even vaccinated, they probably wouldn't survive COVID. So I had to be super careful. Those Ethernet connections are in place. What's next? Let's do the capacitors. Don't feel bad, Joe. I'm having to use PCs to do things I normally use Macs for various reasons. A lot related to component shortages. Yeah, I get that. Component shortages are really killing our business right now as well. In where I work for my day job, we quote these projects for customers for new wireless this or new network switch that or whatever, and we're like, the product exists, but it doesn't exist. I can't get it. I can quote it for you. I can order it. You might not get it until March of next year. So it's just, yeah, I get it. It's freaking crazy right now. So right now we're just putting the capacitors in here, just soldering them in. Solder. Okay. Cut these leads off and get them out of my way. Those are out of the way. There we go. So now we need to do a couple resistors. I don't know which ones I'll do, whichever one I grab first. These are 10 ohm resistors. So we'll do those first. 10 ohms. Well, there's one. And there's the other one. Would you look at that? 2 two 10 ohm resistors, and those go in the 10 ohm holes, which are the ones in toward the middle. You can do it. 10 ohm and 10 ohm, which are really just used for current limiting in this scenario, I believe. Okay. Solder those in place. Let's put this under here so it doesn't move. Make that easier. I'm just putting this, putting the cap underneath here so that when I solder this, I have something to press down against and it doesn't like do this and wobble about and stuff. It makes the work a little more stable for me. Not required. You know, you do things however you want to do. You're gonna like do the thing. There we go. Sometimes the solder doesn't stick for me because my eyeballs suck and I can't see where I'm soldering. There we are, which is why I've got a microscope. So when I'm doing small work, I can see what I'm doing. Okay, those are the 1 ohm resistors are done and out of the way. Or not 1 ohm, 10 ohm resistors. Now we need the 1Ks. 1K resistors. So we need 2 of those. Okay. All right, so where's my little... the previous resistors were all folded over already, so I need my fold over doodle measuring stick thing, if I can find it. I think I dropped it somewhere below the bench and it's gone. Yeah. I have a little 3D printed scale thing that I can use to fold over the leads on resistors. So I can fold over those leads, and so they're the exact width that they need to be, but it's missing down there somewhere. So we're just going to eyeball it, because this is not that critical. It's just not that critical. So it's going to be approximately there, and approximately, I don't know, like that or so, something like that. You can do it. Close, but not quite. You know, we say in engineering, if you ask a mathematician, if you take the distance between you and an object and cut it in half every single time, a mathematician or a physicist will do the math in their head and be like, you'll never get there. But an engineer will do half, quarter, eighth, 16th, close enough for practical purposes. And that's what we just need to be, close enough. Okay, that one's folded over, and that one goes in the other set of holes. Yep. Here we are. Get this one adjust a little bit. It's a little cattywampus. We don't want cattywampus. There we are. Get that soldered in. These are 1K outer resistors. Little interesting thing too about how I run my JCM-1 business and the projects I have here. Each project, or each product, I should say, has its own box. As you see, I grabbed a box from back here, and all the bits and pieces for each project or for each product is in its own box. I have a lot of, how can I say, repetitive supplies for certain things. Like I've got a whole bunch of 1K resistors in this box and a whole bunch of 1K resistors in that box and all of that. And some might say, well, why don't you just get one big bin with just 1K resistors in it and you just pick and choose? Well, the reason why I don't do that is for each product that I design, I make sure that I order the exact parts that I need to complete that project, or to complete that that run of the project, so to speak. Excuse me. And so that means that I can keep track of each project and how many bits and pieces that I have for it to track my inventory for sales purposes. I could keep it all in one big bin, but then it's like, so how many of this part are for that project and how many for that project? I don't know which project I'm running high or low on parts. So I keep them all separated. Gotta keep them separated. Justin, don't feel bad, Joe. I don't have to use PCs. You already said that. Code Professor, I'm in the same position. Family who are vaccinated, but high risk due to other conditions, staying home as much as possible. Yeah, I've been working from home a lot as well. Not doing as many on-site appointments, doing a lot of my sales consults over the phone or through web meetings and stuff like that. Kind of doing tech sales over the web for the kinds of stuff that we do is kind of difficult, but I've been trying to do it. So we got all the actual bits and pieces for that built. Right there, pretty easy, uncomplicated stuff. But now we got to get the wires in. So I have to remember the order the wires go in, which luckily I have this one here that I built as a template, so I know. So it's white, blue, brown, red, green, black. So I know the order, the color the wires have to go in. And then I have to know what color they're supposed to go on that thing. And for that, I have to go look up my cheat sheet because I don't remember how it goes together. But that is okay. So where is the little piece of wire that I cut? Where'd you go? Where is it? Here it is. Wire. So we're going to strip the wire back here. Like so. Easy peasy. Now I'm going to take the nylon doobly-doo out of it. I usually can pull that out because it basically just gets in my way and it's annoying. You can do it. Okay, so we're just going to cut it instead. Sometimes it doesn't pull out. That's fine. Cut and out of the way. So now we got to get all the wires and get each one of them in place. Okay, for this, I'm probably going to change to my microscope because this is much easier for me to do in the scope than it is by the naked eye. So we're going to switch to ScoCam. Da-da-da. Can we do face cam? Yeah, and Twitter logo, there we go. So now you can see. The Jetsons showed off video phones as something futuristic. It took 6 decades before it to become mainstream in the States. Yes. Speaking of that, that's very interesting. While I was at System Source Museum, they have a little PBX setup where you can actually use real, what you might call video phones. It's actually pretty nifty. So let's go ahead and take a look-see here. Yep, I can see that. You can see slightly less of it because of the way the camera works here. But that's okay. We'll make do. So we need to strip these little wires off here. I want to right about there. Just the ends of them. Here we go. Black, brown, brown, you can do it. Blue and red. Somebody is asking here, LXDM, where can I find some schematics for Amiga and other vintage computers for cables, like video cable and so on? Do you know any popular? I just use what my favorite search engine, and what I do is I look for, I put the name of the thing I'm trying to find, so like video or video cable or monitor cable or audio cable or whatever it might be, and then I put the letter of the word pinout, P-I-N-O-U-T, next to it, and it'll tell you what pins mean what, so you know how to hook things up properly. That typically does it. Remember that time when you soldered everything together and noticed you forgot the adapter cover? Yep. Yeah, every single time. Image sensor crop factors, they give me headaches. Yeah, Justin, what it is, it's not the crop factor of this camera. It's the way the entire camera stack is set up. Here, I'll show you. It's the way this entire camera stack is set up. The actual video coming into the camera that you see in the middle of this, in the middle of the screen up all around there, is actually cropped coming into the computer. Not because it's cropping the image, but because the actual how can you put it, the lens objective isn't perfect. It doesn't match what you see in the headset here, because it's made for taking, it's really made for taking snapshots. It's not made for live video per se, and the video portion was kind of adapted after the fact. It has more to do with the actual microscope head than it does the camera itself. If I put any camera in there, it's going to have the exact same crop ratio, so to speak. It's just the way it is. Okay, so looking at our cheat sheet, which goes this way, we need to put black on this side. Black goes right in here. Okay. And we need to do a little focus because you can't see that, neither can I. Focus. There we are. Cool. So we can solder the black lead in place. All right. Next one is green. Green. You can do it, green. Today is your day. Green goes in that one. Let's pull the wire out a little bit. There. Okay. Green is securely in the hole. Yep. Now we solder green in place. Yep, it's good. Green. And then red. Red. Now, Eric said, remember that time when you soldered everything together, notice you forgot the adapter cover? Yep, I'm probably going to do that again. Almost guaranteed. Green, red, yep. And red is in there. Yep. And there's red. Next is brown. Brown. Again, I pull the wire out a little bit. I pull the wire out a little bit here out of the jacket, and so that when I push it into the hole where it seats, it has some pressure against the joint, so that it'll stay in place. And then when I'm done, I shove all the wires back into the jacket. Okay. Brown. Blue. Hello, blue. Wow. You can do it. You can do it, blue wire. Can you see what I'm doing? There we are. Blue. Tell me not to forget something I probably will. Yes. Green Day. At least you get soldering practice, desoldering, resoldering. Yes. Every time. Every single time. And then finally the white one. The white wire, which really isn't connected to anything at the connector side. You can connect it to the ground pin, but it doesn't have to be, because on the back side, those pins are connected together. So they don't really matter. But what else? Put the white one in. Doobie-doobie-doo. There we are. Does that come out? No, it's in there. And so now what we do, Thomas Armstrong, hello. We're going to go back to DroidCam. And so what you can see is these cables have come all askew because I pulled them out to put tension on them so they would stay in place. But now you can just kind of fiddle them all back up in there. Right? Doobie doobie doo. Doobie doobie. And then you can strip this side and get them exposed and pull them out on the other side. Get it all lined up. It's a little tough to do, but when you're done, the cable ends up being all pretty down the end here. You can do it. Use a little excessive force here. A little excessive force. Or as Big Clive likes to say, doesn't he say something like brute force and incompetence? Yes. All right, so that's done. So now we get to do this end. And I remembered this goes on first. That goes on first. And then we put this guy on, which is basically the same process as the other end. Now, I do not need the white wire at all. That can go away. I also need to get an idea of how these cables are going to line up. Are they going to be past the jacket? They are going to be past the jacket a little bit. So I am going to snip just a little bit of them off, just so they're even. And pieces of wire fly all over the place. And the white one does not need to really be connected, so I'm just going to snip it out of the way. Okay, so now we get to do this thingamabobber. So I need to get my cheat sheet, so stand by. I need to find it. I need to find my cheat sheet. It is in my project folder for my projects. Development projects, NeitherNet, sales collateral, cheat sheet. Cool. There is my cheat sheet. Okay. So what we do now is I'm going to switch you back to, I hate that thingamabobber. Yes, every time. Processing data. I need to go to this thing and click back to scope cam and show you guys this, because this is the next thing that we need to do. We're going to pre-tin these little holes. It's a little tricky to do this. There we are. Cool. Focus. Focus, focus. Okay. Now, I'm curious. I've tried this a billion different ways. I've tried pre-tinning everything. I've tried not pre-tinning everything. And I think the easiest way to handle this is actually to pre-tin the wires, put them in there and just remelt it. If you try to add solder to the connectors or to this connector ahead of time, I don't think it works as well. So what you can do is you can pre-solder the wires, put it in there, remelt it, allow it to get stuck in there, so to speak, so it stays in place. You guys can't even see what I'm doing. You're not on camera. Focus. There we go. So like I was saying, I find it better to take the wire ends, pre-tin them, get them put into the holes, and get them all soldered in place so that the cable wires stay in place. Then you can go back around one by one and add a little extra more solder to each connector, so that it really stays in place well. I think that works best. How can we put it? The old adage is pre-tin everything, but I don't think that works well in this particular case because the stuff kind of for whatever reason, it makes it harder for you to see how to get the wire actually in the little cup so you can see what you're doing. So now I'm going to strip these, strip the wire leads off here, and we'll show me pre-tinning those. Also, what happens if you pre-tin the wires, it does a good job of keeping the wires in one nice little bundle, so that when you then put them into the little cup, you're not going to splay wires out the side of the cup or anything like that, and it'll kind of they'll do what they're supposed to do. So let's switch to wire cam 9000 here. So it's hard for you guys to see what I'm doing here because it's just not terribly conducive, but that's okay. It is what it is. So we're going to take that. We're going to pre-tin that. Just pre-tin that. I'm going to do that one and that one. Don't know if you can see those. Probably not. And we'll do these two. I didn't strip quite enough wire off the red one here. So we're going to do that one. I'm going to restrip that wire. Here we are. Okay. Brown one needs a little more solder. Well, they all look like they need a little more, actually. Okay. So now we can bring this guy back into play. We can get those in the spot. Stars Manny, good morning. It's evening here. If you're saying good morning, I presume you're in Australia, New Zealand, Hong Kong, maybe Britain, maybe Europe, someplace not the United States, that's for sure. Or you're being silly just saying good morning. Okay, so now we need to follow our code. So we do red in the upper left corner. So that goes in here. Means we can then melt that solder so it stays in place. Of course I bridged it. Of course I bridged absolutely everything with the world's largest glob of solder. Of course I did. Because of course I did. Welcome to Joe's life, everybody. Making mistakes one second at a time. Let's get that solder blob sucked up off there. Almost. Good enough. Okay. So the red one is in there. Let's remelt that so it sticks. Okay. Red one is in there, and the next one is the green one, which is the upper right corner. Got a little bit of a solder tag on the end of that. Let's get rid of that. I don't need that on there. It's midnight and raining. Sunny England. Welcome to England. Welcome to... I don't know what I was trying to say there. Welcome to you who are in England. Whatever. I don't know. So I need to get the green wire in the connect-a-doodle. You can do it. Green wire is in place. It's a little hard for you to see what I'm doing here. There we go. Melt solder. Just so it sticks and doesn't go anywhere. Now that that's in place, we can actually add some solder to that cup. There, it's definitely not going anywhere now. Okay. We can do the same again for the red one. Since it's in place and not going anywhere. And it has the green wire to keep the bundle in place from moving any place. There we are. In place. Thank you for making us feel better about our skills, Joe. Yes. Yes. My skills are improving day by day. Okay, so the next one we need to do is brown, which is on the left, below the red one. If you look at the color code too, I picked them on purpose so that the warm colors like red and brown kind of went together, and the cool colors like green and black or green and blue went together. Okay. Brown is in place. You can't see it because I'm awful. There we go. That means I should be able to tap a little extra solder in there and get that really well in place. There we are. Now we do blue, which goes on the far side over here. Actually, we do black next because it goes right in the middle. Black is the ground line. Goes smack in the center of the connector. I need tweezers. You can't see anything I'm doing. Tweezers, tweezers, tweezers. Jeebers creepers, where'd you get those tweezers? I'm breaking all the copyright rules tonight, aren't I? Okay, there we go. Cool. So that's out of there. And get the black connector in the place, which goes right in that one. Okay. What microscope am I using? That is a really good question. Stand by and I'll figure it out for you. That one doesn't really want to stay in there. There's not enough solder for it to make good connection. So as long as it stays in place, we can just goop-a-goop it. Once I get this tacked in place, I'll get you information about my microscope, so just stand by. There we go. That one's in place. And finally, the blue one. Which goes right here. There you go. Now you can see what I'm doing. Now you can see what I'm doing. Doobie doobie doo. Come on, solder. You can do it. There we go. Cool. I'm just going to do a quick visual inspection to make sure nothing is cross-connected. It is not. That is good to go right there. So you asked me what microscope I'm using. I have an Amscope. The thing with Amscope is that every single one of them is absolutely customized. I have the 75 times magnification head. It is a triscope, so it's got a binocular. It's trinocular. It's got I'll even twist it here. It's got a dual eyepiece set for looking through, which is very important because that gives you stereo vision and makes working on really small stuff a lot easier. You get proper depth perception that way. It then has the third input right here, which is for the camera, which allows you guys to see what I'm doing. And then the camera here on top is specifically set up for this setup. There is an additional lens that's on there that changes the perspective height of the scope itself, which allows me to have more. Basically, it adds a little bit of extra zoom. It adds like 0.75 of extra zoom to the camera or to the lens stack, so that I can have the actual head higher off the bench and have more room underneath to work. If you want all the specific details about exactly what it is, because I'm really bad at remembering product names and numbers and all of that stuff. Steve Mac 84, Steve of Mac 84, and Bruce of Brankus Creations both have pretty much the exact same setup that I do. As a matter of fact, I asked them both for input, and they're the ones who helped me pick this specific setup. The question, is it expensive? Yes, it kind of sort of is. This stack altogether was somewhere in the, I'd say, just under $1,000 range. I've been saving up for it for quite a long time, and as well as support from my awesome patrons and supporters out there who buy things like these products on my website, and who literally do me continuous support through Patreon, helped pay for this microscope. So it really does help. The reason why I like this microscope specifically is because of things like this. Let me see if we can do the thing. I will show you why. So, yeah, that's a component lead. This thing zooms way super tiny, which makes it really good for doing surface level repairs of boards and surface level SMD component affixation. There are other scopes out there you can get. Yeah, the AmScope, yeah, exactly. That's John Mounts. That is basically the exact same setup that I got. It is pretty much identical. I shopped around a little bit and was able to find that kit for a little bit less than that. Basically, I went direct to AmScope's website and got it because they had some sort of special deal, and I was able to get the whole kit for cheaper than buying it off of Amazon. But it was a timing thing. I happened to be looking, and they're like, "Oh, they're on sale! Yay!" But that price range is pretty much exactly the same. Now, your kit there, you have much crazier magnification. Mine is the 75 times mag, I believe. It's not super deep. Yours is 225, which is absolutely insane. That'll do those tiny little hair's breadth SMD components. So yeah. That said, you don't have to get a super expensive kit like this. One of the other extra main features of this is the quality of its video capture for doing streaming and stuff. I mean, it does a really, really phenomenally sharp job at that. It's designed for this kind of lab environment, right? But there are less expensive little $90, $100 USB cameras you can get. That is basically this one little thing. It has its own little base that you put your component on, and it has its own little lighted camera that lays down from the top, and you have to view it through a monitor, so there's a little bit of lag and stuff to using it, but they're a lot more affordable. So you don't have to like go hog wild to get started with a microscope. You can start small with one of those to really do what you need to do. And then as you move forward, if you find yourself doing a lot of small board stuff, at that point, hopefully you have an income stream that helps afford to get the better tool. So yeah. Having a super crazy microscope is not one of those things that I normally would suggest you go hog wild on. If you're going to go hog wild on a tool, get a really good soldering iron, get a really good multimeter, get really good solder, proper Kester lead-based solder, stuff like that. Don't skip on those things because that's the stuff you're going to be interfacing with every day, and you want that stuff to just flipping work, right? So. Yeah, you went with this one because of the articulating boom stand. Yeah, and that's exactly, mine's not quite articulating. It's kind of hard to see. Actually, why don't we just change cameras? I'll show you which one that I have specifically. Let's go to this one, and then we can switch the camera up so you can literally see the whole 9 yards. So, yeah, here it is. Ah, sweet. We've got like a Drost effect with the screens. So anyway, yeah. So it's got the depth control. It has the focus control. And then it's got mine isn't fully articulating. Mine's the dual slide arm. So it is set up on my bench in just the right spot so that when I'm done with it, I can set it back out of the way, and I still have access back here to my tools, to my what is this thing, the oscilloscope and all of that. But when I need to use it, I just release it. I can pull it forward. It comes out onto my bench area where I can work, and I have plenty of room right here where it is to work on it. If I need more room, if I need this to be farther out, I do have enough. There's junk back here in the way, but I do have enough room of, I guess, non-permanent storage space, so to speak, in this, where I can move the whole base forward and get it way out over the actual center of the workbench. But this setup seems to do a really good job for me, so no complaints. Where are we? Yes, we are putting the thing together. So let's go ahead and change that down here. Ah! Got a floor cam. So that's put together there. So now we have to put these bits and pieces on, which is actually pretty easy. The metal bits go on first, and they really only go on in one place, so you can't really screw it up. So that goes on. And then we put these plastic bits on it. Plastic bits. And again, those only go on one way, so you can't mess that up. And once those are on, you slide the whole jacket up. And you want to make sure that the line or arrow on the jacket is aligned with the keying notch on the thingamadoodle. And that's it. Now, here's a little trick that I do when I build these for people, is that I don't slide this jacket all the way up, because what happens is in some of the Macs, this outer jacket can actually interfere with the plug clearing the shroud, the plastic shroud around it. So I leave it set back a little bit. If you push it all the way forward, you're going to have clearance problems sometimes. And this outer jacket is designed to lock into the plastic. So once it's all the way forward, it is a pain in the patoot to get it loosened out and back out. So if you ever buy one of these kits and you want to put it together yourself, take note of that. That's it. That's an Ethernet adapter. It is built and completed. No, I'm not going to test it on camera because I don't have any of the requisite computers I need set up or available or space on my bench to do that right now. If you don't need to do video, you can get a cheaper stereo microscopes. However, if you want to do video, get an AmScope, or may have trouble finding a camera that works with it. Exactly. So the AmScope, they sell cameras that they have vetted that work with their devices. So it just kind of works. In addition, the AmScope has an industry standard camera mount on it. So you could actually affix any camera you want to that, as long as it has the, I don't know what the standard is called, but it's the same standard that security cameras use, closed circuit TV cameras use, and it just goes right on top, and it works. So no problem there. You didn't have the depth for the dual slide arm. Yours is more stable. Yeah. This camera, with the way I actually have this sliding out at an angle from the corner, because it's not sliding directly perpendicular to the gigantic 45-pound weight that cantilevers it, it's actually not as stable as you think. So I have another big set of heavy junk on it to keep the thing from tipping over. I would really like to have some way to have one that actually mounts to the desk and has a full articulation arm and all that, but it's no. I went with the slidey because it fits the physical space that I have better. Rudy's Retro Intel. Hello, everyone. Hi, Rudy. I saw your messages in your Discord, by the way. I did see those. I was on vacation. That's why I didn't respond. 45 pounds. I'm exaggerating. I don't know how heavy it is. 27, 3 ounces, 56 grams, 470 million tons. I don't know. It's heavy. That's all I know. I went to get it off the porch when it got shipped here and nearly threw my back out. The thing is chonkers. It is super heavy. So NeitherNet is done. What are we going to do next? Let's see. I think that tonight, the next thing I'm going to do is I'm going to build a universal Apple keyboard encoder. If you guys haven't heard about that, it's a little project that I did. Change camera angle so we can chat for a bit. So going back to the history of this adapter, I got a couple of Apple IIe's from Britt Dodd, a fellow Apple, or not Apple IIe's, Apple III's. Apple III's, back here. From Britt Dodd, a fellow Apple II and Apple III enthusiast. And why is this not in focus? Why are you not in focus? And one of them was trashed, just destroyed. A battery exploded. Rats decided to have an all-night freaking rave inside the chassis. I don't know what happened to it, but it was trashed. And I ended up fixing it. But in the process, I found that the keyboard encoder had failed. Now, for those of you who know anything about the Apple III, you know that the Apple III uses the exact same keyboard encoder that the Apple II does, with one exception. The internal key map is different. So you can put an Apple III keyboard encoder in there, but when you press the keys, you'll get different stuff. And up until recently, not to like toot my own horn, but up until I designed the thing, the only way to get a working Apple III keyboard encoder was to steal one from another Apple III. And I was not about to have any of that. I'm about trying to keep the original machines intact and not try to part one machine out for another unless the machine you're parting it out from is totally destroyed and unrepairable. So I set about to design one, and I did. I designed a universal keyboard encoder that worked for both the Apple IIe and the Apple III. But it only worked for those two machines. It didn't work for the Apple IIc because it was physically too large. It didn't work for the Apple III Plus because its keyboard mapping is also different from the Apple III because Apple, right? So then I decided to redesign the encoder again, took a big thought process on it, and was able to redesign it so that it was the same size, almost exactly the same size as the original encoder chip. So it would fit anywhere. And also, it had a universal program ROM on it. So you could just add a couple you could just switch a jumper around on the top of the board and switch it between Apple IIe mode, Apple III mode, or Apple III Plus mode. So basically, it is literally a universal keyboard encoder. It works on any Apple IIe, any Apple IIc, both the Apple IIc and Apple IIc Plus, either one of them. It works in the Apple III and the Apple III Plus. The only machines it doesn't work in is in the Apple II Plus or the Apple II because they have like 20 different keyboards with different encoders. Although there are some Apple II Plus keyboards that the encoder will in theory work on, but you got to know which keyboard it is. It'll also work on anything that uses an AY5 3600 Pro keyboard encoder, or what's also called the KR9600 keyboard encoder. There are other arcade boards and other things out there that use the default off-the-shelf keyboard encoder. This encoder will work for those as well. So it really is a universal replacement for the original AY5 3600 Pro keyboard encoder. And it's for sale on my website if you want one. If you got an Apple IIe or an Apple IIc or a Plus or anything with a bad keyboard encoder, and you've confirmed that it actually is the keyboard encoder by swapping one out of another machine, you can go to my website, you can buy one, slap it in the machine, and boom, problem solved. So that's what that is. So tonight, instead of me here flapping my gums and continue to talk about my own awesomeness, that's a joke. I'm not really that egotistical. We'll build one. So let's do that now. So I need to get the bits and pieces for that. So we're going to go to live stream. I need to switch to Benchcam. Rudy's Retro Intel. Does the encoder work on a Lisa? Good question. I don't think so. Does the Lisa have an AY5 3600 keyboard encoder in it? I don't think so. It has its own custom chip, its own custom kind of serial encoding format. I don't think it uses that encoder. Stand by while I get the box that has the stuff in it. As always, I have dedicated boxes for this project as well to keep all my bits and pieces for each one separated. So the first thing we need is the adapter board, which is that right there. That is the adapter board. Is that the correct version? It is. So there's the adapter board. We need the resistors that I use, little surface mount resistors. I need a soldering jig. I will need the pin header thingamabobs so that you can choose which ROM it's going to be using. And then I will need what I call Arduino headers, because that's how I put pins in this to make it like a 40-pin chip to put into a board. Stand by. Cameras might shake and go all over the place because I'm reaching around the cameras here. We need those things. And then finally, last thing that I need for this project is in this box here. This right now is the most expensive box on planet Earth, because it contains chips that when I bought them cost 87 cents a piece that now cost $4 a piece. These are the PIC microcontrollers that I use for this project. These PIC microcontrollers are PIC 16F18875. The reason I used it, I picked the first microcontroller I decided to learn how to use was the PIC microcontroller, because the programmer for it was cheaper than it and I was able to buy it and it just worked. I don't know. That's why it's the chip I picked. So the upside to this project is this is 100% microscope based. So we get to switch to scope cam. You get to watch me do super micro soldering. So we're going to go to scope cam. Zoom way out. We're going to focus a little bit. Here we go. Okay, so first things first, we need to get the chip installed. Oh my gosh, Bruce Brankus Creations, dude. How are you doing, man? We were just talking about you. Some of the folks in my chat, Bruce, were asking what microscope that I'm using. And I'm basically using the same microscope and a extra little objective lens that you use to give you more working room under the microscope. So if you happen to know what that is, I'm going to drop those product names in the chat. Throw them in there. I'd appreciate that. Not required, of course, but you can if you want to. So let's go ahead and get the chip here. Now, you'll notice in this corner is the dot indicating pin 1 of the board itself. And that actually corresponds as well to the dot in the upper right corner or upper left corner of the chip. So I orient those in the same manner on the board when I put them together like that, right? That's just how I designed it. So we need to just go ahead and get that put together. So we need a little bit of goop solder flux. Again, thanks to Bruce, this is the solder flux that he uses. I use the same stuff. It works really well. It is Amtech NC-559-V2-TF. It is super sticky. It keeps the product in place. And most Barlow lens, exactly. I knew it started with a B, but I couldn't remember what it was called. Thank you. It's this stuff, flux, is really sticky, and most importantly, when you use it, it doesn't stink. It has an odor to it, but it kind of almost smells like warm tallow or like fresh home cooking. It's a weird smell. It's more chemically than that, but it more smells like a burning fat than it does like somebody dipping something in hydrochloric acid, and it makes you want to leave the room. So it's really good stuff. Stars Manny never really understood the difference between a microcontroller and a microprocessor. That is a really good question, and I'm glad you asked that. So the primary difference between a microprocessor and a microcontroller is that a microprocessor is typically the brain by itself of a computing architecture. And it typically will have its RAM, its ROM, and all of that stuff external to the device. Whereas a microcontroller will usually have a processor. It has a microprocessor in it, in addition to internal RAM, internal ROM, and also usually I/O devices. So, for example, this microcontroller has a PIC microcontroller core on it, but it also has a whole bunch of I/O pins, that you can set to be high or low and all that stuff, and you don't have to have a whole bunch of extra support circuitry to use it. It just, you solder it in. It's got like serial input output pins and parallel input output pins and clocks and timers and pulse width modulation and all this other extra cool stuff. So you just throw the chip on there and you can program the chip and it just works. Eric Miller, smells like victory. Yes, sure. I'll take it. So now we're going to solder 2 corners of this chip. Now, if you look really carefully, I spent all that time I was talking. I was spending time getting the chip well aligned. It's not perfect, but I don't have any like pads crossing over each other. So that's all that's really needed. It's just got to be kind of on there. I find the more I try to fiddle with these things to get them perfect, the more they end up being imperfect and not being in the right spot. And it just makes me grumpy. So I usually just kind of get them close, as long as they're close, and then I'm a happy camper. So we got that on there. So now we're going to solder the pin in place. You want a beer? You'll be right back. I wish I could drink beer. For those of you who don't know, for those of you who follow me, you know why I can't drink. But for those of you who don't, I take an antidepressant. Really, it's a anti-anxiety medication, and that it no compatible with the alcohols. So I can't do that. But oh my God, I would love to have a beer right now. You have no idea. Okay. There we go. That is on there. It's not quite in focus. Can I change the focus just a little bit for you guys? That's better. So now we add flux all the way around it. And then we solder all the pins. Go on there, flux. Go on the pins, flux. Thank you. There we go. And there we go. Awesome. So now I'm going to use a variant drag solder technique. What I do is I drag solder each pin individually. It tends to work better for me for this specific chip on this specific board. Usually if I try to drag solder across the pins, something funky happens, and I usually almost always get massive numbers of bridges, solder bridges across the pins. I don't know why. That's just the way it decides it wants to be. So usually I just add a touch of solder to the end of my iron, just kind of go across the pins. There we go. Just reflow each of those pins. Doesn't matter how much flux I add for whatever, there's something with these particular chips and this particular layout that I designed. It's just grumpy and it doesn't like it. Okay. Do this pin set. Okay. Yep, and there we go. Look at that. I got a bridge. That's what happens when I drag solder these. For some reason, I don't know why. The pitch on these is super, super fine. Probably just not enough flux. It doesn't seem like it doesn't seem to matter how much flux I add, though. It doesn't like it doesn't behave, but that's fine. Doobie-doobie-doo. Okay. Let's do these pins next. Never found like for coffee either? You don't like coffee? Oh, what a shame. Tasty. MU500, yes. Rudy, I only drink red wine so I can see it when it spills on the computer. Yes. Okay, those pins are soldered in place. Oh, no, that bridge is gone. There we go. I may also be using too much solder. There's lots of little reasons why you can get solder bridges across pins. But I use the method that works best for me. And that's really the lesson to take from doing this stuff is watch a lot of different people doing the same thing. And you'll find different people have different methods that they find that works for them. And then you can copy their methods. Try one or the other or this or that and see which method happens to work best. Yep, I got a bridge there too. Probably too much solder. There we go, got rid of it. Okay. Now I'm going to do a super zoom real quick to make sure that these things are super good. Apologies for the shaky camera. That set's good. That set's good. That set's good. That set's good. Good, the chip is in place. Now we get to do the resistors, which are kind of tedious, but that's okay. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This project takes exactly 10 resistors. I want to redesign, once these boards are done, I do want to redesign this board slightly to see if I can get a 10 resistor single chip pack, if that makes sense, so that I can reduce the process, the amount of time it takes to do this, building these. Not that it takes a really long time or anything, but okay, so the resistor pack is open. I need something to put the resistors in. Stand by. There we go. All righty. Resistors are all in one nice little place there. They're in this little bin. See? Okay. Time to flux-a-doodle. There we go. Plenty of flux. Probably too much, but you can never have enough flux. Stuff's cheap anyway. It's easy. Okay. Need to have my solder handy to retin my iron as I do this. Okay, just make sure you guys can see what I'm doing. You can, yep. Iron, the chip is in place. And it's not quite in the right spot. There we go. A little bit more. There we are. And chip. That one's in place. I put my hand right in the resistors, and now they're all stuck to my hand because, of course, because my name is Joe and I'm clumsy as heck. I'm going to count them, make sure they're all there. 1, 2, 3, 4, 5, 6. I lost 4 somehow. Okay, well, we will just proceed and see if we'll just proceed. Yeah. Stand by, I'm counting resistors. 1, 2, 3, 4, 5, 6. Yep. No, they all made it in there. They're not stuck to my hand. All right, well, apparently we're going to need more resistors. Yeah, that's fine. Okay. That's the problem with these tiny resistors is, or any tiny component like this, you look at it wrong and they disappear. They're gone. They are gone. Okay. Do this one. That in focus for you. Can you see that? Your focus is slightly off from my focus. It's just off just a little bit. There we are. There's that one. And next. Resistance is futile. Yes. I actually, for the longest time, I had a little picture up here on my backboard. You may have seen it before. It was a picture of Lieutenant Commander Data from Star Trek The Next Generation. He said, resistance is not futile. It is voltage divided by current. There we go. And next one. Move that up so you can see it. Now, these resistors are very important for the function of this controller, and I'll tell you why. So, the original whatever you want to call it, controller chip has built-in pull-down resistors on these inputs. So you don't have to add resistors to your circuit for it to function correctly. But this microcontroller doesn't have the ability for me to set these in pull-down mode. I can set them in pull-up mode, but not pull-down mode. Or vice versa, one or the other. It doesn't really matter, but basically it needs these resistors to pull it to a specific rail so that it doesn't receive spurious inputs. Well, because the original has those built in and this one doesn't, I have to adjust for that. So we have to add resistors to fulfill that option. The reason why that is needed specifically in electronic circuits, and that is because that a logic circuit needs to have its device at a known value every time it reads it. If you leave an input floating, for example, if you leave it to where it's not tied to either 5 volts or ground or something else that tells it what that value is always supposed to be, what happens is it's going to interpret what it thinks the value that's supposed to be based on literal, like random noise. And so that means that your input's going to be 1 0 0 1 1 1 1 0 0 1. It's going to be floating all over the place, and you're never going to get a good read. It will never float all the way down to 0 or all the way up to 5 volts for you, or 1 logic 1. It'll just be all over the place, and you'll never get a reliable value out of it. So you need to have a pull-up or pull-down resistor that either pulls it up to logic 1 or pulls it down to logic 0, so that input is in a known value when you expect it to be. A lot of focus. A lot of focus. There we go. That's a little better. Let's see. Have I ever tried doing this without a microscope? Yes, the first several of these that I built them without a microscope. I can do it without a microscope, and I can show you if you like. It's a pain in the butt, but it is doable. You wish you had gray hair. Okay. Somebody said some of those high-res amoscope cameras take beautiful still images, but really sluggish with video. Yeah, and that's that is the case with this. There is a little bit of delay on the video of this camera. My OCD can't handle the resistors being different ways up. I'm sorry. Now, when I do resistors on for through-hole stuff for my customers, I absolutely do everything in my power to make sure they're all oriented in the same direction. The same with the capacitors and everything, so it looks nice and prim and proper. When I'm doing this low-level stuff, I don't have the time to do that, to sit there and try to futz it and get it oriented the right direction. It's a resistor. It literally does not matter. If it's in there, it's in there. If you ever order one of these from me and you do have an issue, and I'm not meaning to belittle, but if you do have an issue with them being in different directions, just put me a note on the order, say, Joe, they have to be the right direction or I'm going to go crazy. And I'll make sure that I do that for you. Trust me, I am sympathetic to people's proclivities. I cringed because one was oriented differently, but not electrically. Yeah. Resistors are monopolar. You can put them any direction. They do not care. They just work. Okay, let's get this resistor in place here. Need to add a little extra solder to my iron, just a little bit. There we are. Get aligned. Aligned, aligned, aligned. Close enough. There we go. That one's in. And now I need to get a few more resistors because apparently I kicked 3 of the resistors across the bench and into nowhere. I'm literally staring at my bench here, trying to find these resistors and where they went to, and they are just gone. They have vaporized. They have utterly, utterly disappeared. Okay, that's fine. So I have extras. I have more of those than I need for my projects. So I need 3 more. Is this going to be like Zeno's paradox, where every time I get out 2 more, I'm going to need 1 more, and I'm always going to need an extra one, no matter how many I get out. I'm going to be like soldering for the rest of until the end of infinity. Okay. So let's get these out of here. Okay, did you guys want to see me do one of these by hand? One of these, or by eye, I should say, because I can do that. Let's switch cameras. Processing data. I need to switch to this camera. Let's see if we can get in super close so you can see what I'm doing. So you can see what I'm doing. Come all the way over here. Okay, so we're going to do one by hand. I have done it before. It's how I used to always do it. I am doing it a little bit weird here too, because I'm trying to get the angle so you guys can see what I'm doing. I don't usually do it quite this oddly. There you are. Done by eye. Can we do it with one eye closed? No. Nice one. At least they aren't quantum. It's Taco Tuesday. Yes. Can we see you do it by foot? No. That is an explicit no. That is a refusal of that question. Scope cam. Do these last 2 here real quick. Real quick like. Oh, come on. My fingers are all wobbly today. Probably too much coffee. There's not enough solder on that iron. Let's try that again. Perfect. Just remelting the solder on all those. Make sure it really fixes to the pad. Because I have had problems with these where I go to put them together and the resistor actually looks like it's on there, but it didn't affix between the resistor and the pad. It's just I have a tendency now to go over them all again. Okay, final resistor. Need more solder. Solder. Okay, that side is reaffixed. I'm going to rerun the other side real quick. Okay, those are all on there. Cool. So now we get to do the macro soldering stuff. Switch camera again. You get to see macro soldering. Is that a term? Macro soldering? I don't know. I'm just goofing off and making stuff up. There we go. So now we need to do these things. The actual pins that go through. And I use what I call these are Arduino headers, if you want to call them that. They're used in Arduino projects. Pardon me, I'm going to sneeze. Excuse me. And they work great because you can put them these cancellation holes in the board, right? And so these can go through the board. They can go through the board like so, right? And then you can solder them in place and then snip them off, and then you basically made a 40-pin chip out of a PCB. So cool stuff. So I've created a jig for this process to make it easy for me, to make sure that the pins have the right depth so that they're not too long or too short or whatever. So basically, it's just it's a 40-pin socket connected to a piece of perf board. And then I just lay it so I can emulate the actual depth of a real socket. Then I put it in there. Oh my gosh, not focused. Can't see a damn thing I'm done. And then that. So those go in there like that. I tend to fold the pins over just so they're out of the way. Now, in theory, I can do this by eye, but I actually like to do this in the microscope. Are those 1206s? That's a good question. Those are 0603s, I think. It's a step down from that. Dave's Vintage Apple Tech. Hello, Joe. Yeah, you were streaming earlier, weren't you? Scope cam. Yes. Yes. Change the focus so you can see it. There we go. And I find it's easier to do these under the microscope as well. It's actually easier to do almost everything under the microscope these days. I'm like, oh, I don't need to do that under the scope. And then I ended up finding myself doing it under the scope. I'm like, oh, well, that's why I did it under the scope. So then we just solder these pins in place like this. Okay. And then we snip them off. One down, 4 to go. Just finished. Those are small. John, you really should see. I've got 0402s or 0204s or something for a project I did for Mac Effects, actually. I can't say a lot about that project, too much about it, but we were doing a project and they needed super, super, super tiny ones for that, just to fit in the space that we had available to fit them in there. And oh my gosh, yeah, you absolutely really do need a microscope for that. Although, on the first couple runs of that board, I did it by eye. Smaller than these, smaller resistors than these resistors. Absolutely minuscule. Those are done. Okay. 3 more to go. Okay. Doobie doobie doo, doobie doobie, doobie doobie doo. And that one's done. Okay, 2 more. Yes, I count them as I go because I'm nutty. I'm a little weird, just a little bit. Okay, that one goes in there. And fold over. Do I use a fume extractor? No, I do not. I do not use a fume extractor. When I've got a lot of fumes, if I'm doing a ton of soldering, what I just use a fan and I just kind of blow it at me to blow the smoke out of the way so it's not right in my face. I have a nice wide open space down here, and I'm usually not soldering so much all at once that the entire place fills with smoke, so I'm not terribly worried about it, to be honest. But yeah, I've got this. Well, here. It's stuck. It's stuck. Unstick. I just got this spare Noctua fan that I have wired up that I can plug into my bench supply over here just to kind of blow stuff out of my way. Nice solution, Joe. Thank you, Eric. I appreciate that. I got this trick from Jeff Burt of Hey Burt on YouTube. He uses a similar trick to this for his 8701, the timing chip replacement for the Commodore 64. And I saw that, I'm like, this is perfect for miniaturizing the keyboard encoder. And that trick allowed me to miniaturize the keyboard encoder and make it truly universal and work in literally anything. So props to Jeff. I do appreciate that. And one more to go. This is a half and half. So 4 pins go on one side, like that. It's nice to see soldering of shiny new composed where everything just flows beautifully. I've been fixing a battery bond Mac SE30, and yeah, Craig, when the trick to that is lots of heat, lots of solder, lots of clean heat solder, clean heat solder. What happens is all the solder ends up getting turned into lead and tin salts by the acidic components, and it doesn't actually flow like solder. So you've got to mix extra solder into it to change the eutectic mixture and that balance to get it to actually flow. And you just keep at it and keep cleaning, keep cleaning, keep cleaning, and eventually you'll get it all cleaned off of there. That's the trick. Keep adding solder. Lots of flux too, because the flux helps dissolve those salts and get them out of the joint. Can never have too much flux. The solder I'm using is Kester, good old-fashioned Kester 6040 tin lead. Nothing fancy about it. Rosin cord. So it comes with the flux built into the solder. So for just quick joints and stuff like that, you don't have to add flux. It's already in the solder. Apparently there's an 01, 005 component size. No, absolutely no. If you need an electron microscope to solder it, you're in the wrong business, brother. Yeah. That's where which one of you said you had the 225 zoom? That's what the 225 zoom camera is for. I don't think I could do that with this camera or with this microscope. I think it would still be too small for me. I'm not sure I would have tools that could do that, like the soldering iron and the stuff like that. I'm not. Nope. Okay, so we got this all put together. Should you try to remove as much of the old solder as you can first? Absolutely, yes. When you're fixing old boards and stuff, when the solder has been turned, if it's not nice and silvery, if it looks matte finished, it looks like a dull gray. And if you take a pick or something to it and you scratch it and it feels like scratchy, there's like voids and pits in that solder that have been eaten apart by the acid and turned to literal metal salts that are like sometimes even water soluble. But yes, you need to add solder, clean, add clean, add clean until the pad is shiny as a mirror. And you just keep doing it until all the crap is off there. Old solder, gone. But again, only where it needs to be done. You don't need to necessarily go on every joint across the entire board and resolder the whole thing, just the focus areas. If you went and tried to resolder the entire gosh darn board, you'll be there for days cleaning that board up, and it's just not necessary. Yeah, a really soft and crumbly can pick apart is easy. Yeah, powderish. Yeah, thanks. Pre-wash. Usually pre-wash isn't always necessary, but it depends on the condition of the board. So if the board is battery bombed and the battery crud is still on the board, absolutely. You're going to want to get all that junk off the board just to get it out of your way, so you're not confusing or you're not getting like it's just so it's not in your way. Will a dishwasher work? In theory, yes, you can use a dishwasher to clean those boards. You would run the dishwasher without any detergent in it, or if you do use a detergent, you probably don't want to use regular dish detergent. That may cause damage to some of the metal components. It may, but not guaranteed. It depends. The best way to clean in my opinion, the best way to clean a battery bombed board before you work on it is a good old-fashioned scrub with a medium bristled brush, not super hard plastic bristled brush, but not super soft either, like a soft toothbrush, something kind of in between with, believe it or not, Windex. I kid you not. And you get all the crud out of the way. From there, you can do a quick rinse with water, and that way you can see what you're working with. Some folks out there, Bruce probably here in the chat, they'll like to do a preliminary ultrasonic clean in an ultrasonic cleaner if you happen to have one of those. In my opinion and experience, that's not necessary, although an ultrasonic clean when you're done or what is close to that as you can approximate it, absolutely. Because even though you're getting the junk out of the way so that you can get the repair completed, surface mount stuff or anything underneath chip sockets, stuff like that, if any of that goo from the battery or from capacitors gets underneath any of that stuff and then gets a little bit wet, that can reactivate it, and then it can start to eat the thing again. And you need to make sure you can get way underneath all of that and get it all out of there. Especially too, if you have chips, if you've done a repair and there are chips that look bad or look nasty, but everything seems to be working okay. If you have the ability to remove those chips, clean all the area up and resolder the chips, that's good too, because you're getting all of the remnant residues and stuff out from under those areas, so they can't continue to do damage. So yes, pre-clean, I just usually do the scrubby scrub, and then I will do a really nice long hot ultrasonic cleaner clean after the fact. Let's see, Kester solder is the best. You're using lead-free. That's cool. Yep. Not all lead-free solder is created equally. Yes, you have to be careful with lead-free solder. Some of the high, how can I put it? Some of the high silver content solders can be a pain in the butt to work with. Distilled water final rinse, that's up to you. I typically just use tap water. As long as you get it dry, and as long as the tap water in your area is not like super crunchy, it's not super hard with a lot of mineral junk in it, it should be fine. My local car wash worked. Yeah, capacitor replacement. Yeah. Embarrassed to say you have a Performer 550 with a layer of dust on it. Yeah, so you're going to check under that dust, right, to make sure that it's hasn't turned into dust and into dust turds where it mixed with the leaking electrolyte, right? Right? Make sure you do that. Yeah. But yeah. So yeah, that's my opinions on the washing. I don't know how to say it. I mean, different people have different experiences and scenarios in which they like to do the ultrasonic first, or they like to do the ultrasonic last, or whatever. And it really does come down to personal experience and trying it. The cleaning is absolutely freaking needed, though. You need to get the crap off that board. You can't just throw chips on the board and leave the chips and new capacitors and stuff on the board and leave the electrolyte on there, because it's going to start eating stuff and causing more problems. So a Crest ultrasonic cleaner is my future, but not the near future. Yeah, ultrasonic cleaners can be kind of pricey. You know, they're the inexpensive ones are like a $150 for a nice sized one, and then they just go from there, you know, depending on how crazy you get with them. So, okay, back to Benchcam. So that has been built and all put together. So next thing we need to do in this, I need to get the selector pins. So I have these jumper pins that go in the board here that just cross together some of the pins on the controller, so that when the controller turns on for the first time, it knows what key mapping to use, and that's what this does. So I solder those in place, and I put a little jumper shunt across that to do that. Hesitant because of water plus electronics. Water and electronics are not a problem at all. You can use water on electronics as much as you want. As a matter of fact, in most circuit board manufacturing places, what do you think they clean the board with when they're done? Water. They use water, lots and lots of hot water. Water will not hurt your electronics. Your electronics are waterproof. The only thing, water itself, by itself, for example, distilled water, doesn't even conduct electricity. It's the crap in the water that conducts electricity. So as long as you get it super duper clean and you're not cleaning it with super hard, you know, like calcified water, and you get it perfectly dry before you turn anything on, and I mean dry, right? You'll be fine. You'll be absolutely fine. The way I dry my boards is a combination of an air compressor. I have an air compressor right down here. You can't see it. Can you see it? Down here? No, you can't really see it. I have an air compressor specifically for the purpose of blowing boards dry and getting the majority of the water out from all the little crevices. After that's done, I then put the board on top of my dehumidifier that's out in my garage and let super crisp dry air blow across the board, and I can get the board dried out in like 5 or 10 minutes. But if you don't have that solution, let's do the Ina Garden. Well, if you can't get your super expensive air compressor from Germany, store-bought will be fine. Basically, you hang it out to dry. You shake the board out really good. Just use centrifugal force to shake all the water out, and then you just set it up on its side so it can drip dry, and you leave it there in a nice warm room for, I don't know, a day, and it'll get dry and it'll be fine. Nothing to worry about. Throw the water at it. It don't care. So now we need to solder some more stuff together. So we got to solder these pins here. Right on there like that. Wanted to get an ultrasonic cleaner that would fit any board size I could conceive. And I saw the price. I'll see what 150 can get me. Yep, pretty much. You can do what Bruce did, Mr. Brankus Creations. He built his own ultrasonic cleaner, which is a thing you can do. It's actually not that hard. If you're to the point of being able to do this electronic stuff, putting together an ultrasonic cleaner is cake. It's an afternoon project. Okay, so let's get these pins soldered on. If you know what you're doing, it's actually pretty inexpensive. It's cheaper to do it that way than to buy one. Okay, I want to make sure those pins are nice and aligned and straight, and they are, before we solder the rest of the pins on, because the last thing you want is a crooked pin header. There we go. Those are done. And that is one completed and built chip. One day I'll get around to releasing the video on how I made the ultrasonic cleaner. Yes, Bruce, we have been waiting for that. We have been waiting ever so patiently for that. So now that this is all completed-doodled, all built, let's switch to here. Now we have that all built. We get to come over here to my programmer and program it. I'll show you the programmer, but I got a lot of crap on my screen, so I'm not going to show you my screen. But basically, this is the programmer I use for it. This is the Microchip Curiosity HPC, which is really designed as a design kit. G'day, mate. Sorry I'm late, but work got in the way. That is fine, Michael. That is not a problem. And that's why I'm streaming tonight, because work for me has been crazy and I needed to hang out and just veg. So it's all good, man. But this is kind of, I don't know, it's one of those STEM development kits. It was the cheapest programmer I could find for the chips that I use. Super easy. And so what I did is it has, oops, stand by. I'm doing a thing. It's got just a socket on the board down here underneath, and I soldered with an adapter doodle. I soldered a 0 insertion force socket on top of that, so I could program the large-scale 40-pin chips of this. But as we know, that's not a 40-pin chip. That is a 44-pin quad flat pack, right? Focus, you fork. There. So that means that's not going to work on this, right? Doesn't work. So what I did is I figured out which chips or which pins on this chip are required to actually program it, and then wired those to known pins on the PCB, so I knew where to route signals to. And then I created this little adapter board, this little zero insertion force adapter board. Focus. That then goes on top of this one, so I can program these chips in that programmer without having to buy any extra funky programmers and spend a bunch of money on it, because I am the cheapest person on earth. I am super duper cheap. Stand by. I'm putting the stack back together here so we can get it plugged in and program this chip. Try to find instructions for building an ultrasonic cleaner, because I like the cleaner better size for PCBs. Yeah, great blog post. I had nothing to do with the ultrasonics. Yes, Bruce, seriously, the moment you create that do-it-yourself ultrasonic cleaner video, that's going to be viral. There's a dearth of information out there about that. You really need to put that up. Everybody, pressure him. Pressure Bruce. Bruce, do it, man. Do it. Do it. Do it. Rudy's asking which encoders you sell the most of these. Well, they're universal now, so they're all the same. I'm not sure what you mean. If you mean the ones, because you can purchase this with two different options of whether it has the pin headers on it or whether it doesn't have the pin headers on it. I sell them with the pin headers on it slightly more. But the one without the pin headers on it are usually for folks who are ordering it for the Apple IIc, because with the pin headers on it, it won't clear the keyboard. The keyboard will touch the bottom of it and short out, so it doesn't have there. So let's get this in the adapter doodle, in the programmer thingamababa. Get the programmer plugged into the computer. And it is all plugged in. Now I need to launch my program, which is MPLAB XIDE. It's the programming tool for PIC microcontrollers and all that stuff. I need to open the project, which is weird, and you're going to hear my computer make a lot of dingy noises because of the way this application works, and it's stupid. I need to go to Universal Shortboard. This one. Loading project files. There is the code. There is the code. Now, I have done a video on designing this this keyboard encoder. There's a video in the I think it was a live stream or something I did in the past about designing this encoder. So you can go hunt that down if you want to look at how the code works and all of that stuff. So we're going to do the build-a-doodle. We're going to program the chip. And now I'm getting problems with it actually doing it because it's being stupid. Stand by. It's complaining about file permissions or something because I renamed the folders things were in. This MPLAB XIDE program sucks. It is awful. John Morris, hey Joe. Is that the John Morris who does applesauce, or is this a different John Morris? Let me know. Downloads, not downloads. It's on my server under Documents. MPX Lab X Project, Universal Encoder Shortboard. This, and then I need to like do this and do properties and do security and make sure it's set. That's set correctly. Yes. Oh, now what happens when I do build? If you're going to hear that alarm go off a couple times, that's my alarm reminding me to take my medication. Guilty. I saw your post, John, of the applesauce update. I am watching that with great interest. For those who might aren't Apple II folks, yeah, John Morris is an absolute awesome guy who created the applesauce project that started as the ability to image Apple or Apple II disks, but now it can do Mac disks and Commodore disks and a whole bunch of other stuff. And as he continues to develop that, I see applesauce being pretty much the preeminent fluxer for images and stuff. So yeah. So why does this say does not exist or is not an executable? Because I've renamed the folder. And it's being dumb. It says default production universal dot hack. Why can't it find it? So here, there's this. I apologize for this pause. There's this issue with MPLab XIDE from Microchip that if you change the name of the folder your project is in, it gets confused, and then will tell you that the path name that it's trying to put the file in, which is the correct path name, and it shows you the correct path name on the screen. It shows you, it tells you that like it can't export it because it's trying to export it to some other location because you changed the name of the folder instead of like changing the name of the project or something. It's dumb. It's stupid. So like, do I need to rename it to be the same as the folder name or something? I'm trying to remember how I fix this problem. Copy. Crowdflux double minus bad. Double plus ungood, right? Anybody want to buy mine? Yeah. Not me. I need to do a rename. To that. And then do rename. Now that it's renamed, will it work? No. I don't care. So rename the whole gosh darn thing. So rename project folder. Now that it's renamed, will it build it? Yes. Okay, it's done. So now it's building. Good. So now I can click this button and program the chip. Connecting to programmer. Found the programmer. Found the chip. Program verify complete. That is one completed encoder chip. So now we get to switch over here and plug it into this Apple II and see what happens. So I'm going to set up camera real quick, and you get to see how the sausage gets made. This up here like this, and kind of put that down there like that. Put that over here. Move all this project stuff. Lots of projects going on. Okay, let's switch cameras. Switch camera to that one. Making sure I don't have anything confidential in that camera shot. I don't. Okay. Pop that open. If you look in here really closely, this Apple II is specifically designed for testing these chips because I have a zero insertion force socket in there. It's soldered directly into the board. I have a chip already in there that I've made previously that I actually made wrong, and if you look really closely, I had to fix. I have a little bodge wire on there because I fried it, but you know, whatever. I'm not perfect. Okay. I actually do, because I'm paranoid, I am going to check this under the microscope real quick. Stand by. Make sure I don't have any bridges or anything. Nope. Looks good to me. Okay, let's get this chip in here. Chip goes in that direction. Okay, that is in there. We need to turn on the monitor. Okay, and we turn that on. Sweet. Cool. Okay. It's working. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Dash equals delete. QWERTYUIOP blah blah blah. I hope you all can hear me. My microphone is back here. ASDF. Did I hit space? Yeah. ASDFGHJ. Enter. Yep. Okay, we'll make sure the shift key works. Z, 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 Z. It does. Make sure control works. It does. Okay, make sure shift in the top row works. It does. Ta-da! Working keyboard encoder. So we can shut that computer down, take that encoder out, and that encoder is ready for whoever wants to buy it. You need a keyboard encoder? I'm your Huckleberry. Okay. Switch back to benchcam. Yoink. So now we need to clean that encoder because it is full of flux gunk. Sound level is goodly. Yay. Just bought my first ever 2E, waiting for it to arrive. Woo! Woo! Apple 2E in the house. Yes. So stand by. I'm going to rearrange things a little bit to make this a little easier for me to do my job. Stand by. Just a little rearrange-a-doodle. I just need the camera a little bit back out of my way. Put that out of the way. Put this over here. And so what I use to clean these is a stiff-ish, but not super stiff, toothbrush. And a combination of isopropyl alcohol and Windex. Because with this stuff, I find the isopropyl alcohol doesn't get rid of the flux completely, but the Windex along with it helps get rid of it. Yes, is it blasphemy to use Windex on cleaning these boards? Probably. Is it bad for the metal? Maybe, but I don't seem to have a problem with it. So, speaking of ultrasonic cleaners and Windex. It's quite interesting. The ultrasonic fluid in my ultrasonic cleaner, it doesn't smell like Windex, but it does smell like one of the sanitizers that I used when I worked in food service when I was much younger. It smells like the same sanitizer we used to clean tables and stuff. So if it's good enough for that, it's good enough for PCBs. That's my rule. Okay, so now I'm going to make a loud noise. I apologize in advance. We're going to get the compressor nozzle out. We're going to clean it. We're going to dry this off. Right here. There we are. One super duper clean chip. Ready to go. Ready to be shipped around the world to my awesome peoples. There's that alarm again. I'm going to snooze that again. I'm going to keep snoozing that. It's going to go off every 9 minutes. I apologize for the noise. If I do not let it go off and I turn it off, I will forget to take my medication and I will be sad boy tomorrow. And you don't want that. Okay. Rudy had to leave. Thanks for a great time as always and for sharing. Ciao. See you, Rudy. Thank you for stopping by, man. Absolutely. What strength? What strength? What? Strength isopropyl alcohol? Strength of Windex? Literally, it's Windex brand. The isopropyl alcohol I use is 99.99 medical grade or professional grade. It's or 99.9. It's that stuff right there. It is specifically designed for cleaning electronics, and it is anhydrous. It means it has no water in it. I keep it tightly sealed, so it keeps the water level inside it as low as possible. The Windex I use is actually commercial grade Windex as well. I get that in bulk from the local hardware store, and it's stronger. It's made to be diluted, but I use it at full strength, neat, and it seems to do a really good job at getting all of the stuff off the board. I mean, here we'll zoom up, and like the only thing that's left on that board, if I can get it to focus, you feck, do it. Get a good angle. There's a tiny little bit right on the chip. See that tiny little bit there that came out from underneath the chip, but otherwise it is perfectly clean. So it does a really good job. I tooked mine. Perhaps I'll not. Yes. We need our meds to keep us sane. Yeah. So that was my plans for tonight. For all those who came in late, the actual original plan, you might have seen it on the stream note, was I had an order come in while I was driving down the highway yesterday on my way home from vacation. And the order was for a NeitherNet adapter for one of them guys, and it was for a soft card, my soft card 3, which is it's the CPM compatibility card for the Apple III computer. And I was like, yeah, we'll go ahead and build those on stream. That'll be really cool. And then I go and I actually look at the order, and they were build-it-yourself kits. So the person who purchased them wanted to build them themselves. So I couldn't build them on stream. I can't really, I don't know, how can I put it? I can't deprive them of the joy of building their own kit. So we built other things. So it's all good. Well, I think I'm going to probably wrap things up for tonight, because now I actually have to put these kits together for this guy, and I'm sure you don't want to watch me just put things in boxes. That's boring as heck. But yeah, need the IP for alternative photography processes, so that's a good thing. 2 hobbies for the price of 1. Yes. What is that's a really good question. What is the IP used for in the photography process? Do you use it to manipulate the fixing rate of the whatever, the chemical that fixes the grains in the film, or what? I'm not sure. But yeah. Any thoughts, questions, comments, rants, raves, chat stuff you want to talk about while we're here and while I'm on stream? Throw them in the chat, and I will answer questions. While we're wrapping up, just a super quick reminder: these things that I built tonight are available on my website, jcm-1.com, along with cool nerd merch like shirts and mugs, like this cool drinking mug and stuff like that, stickers, all types of neat things that you can get over on my website. And those things help me fund my hobby and my channel and these things for you. So that is a place you can go to do that. If you want to support me and my efforts directly, you can go to patreon.com/Joe's Computer Museum. I will see if I can put that in the description. Stand by, because I didn't put it in the actual description. View page. To make solutions that are not water soluble. Got it. View your public page. I need the URL. This is my Patreon URL. There it is. That's my Patreon link, so if you want to support me directly that way, you can do that. Craig Chamberlain says, this was my first live stream on YouTube ever. Very enjoyable. Thanks, Joe. I am glad that your first live stream on YouTube went well, and hopefully you'll be able to watch some of the other folks that live stream similar things to me, like Bruce from Brankus Creations and Steve from Mac 84 and Dave from Dave's Computer Stuff was in here, and there's several other people in here. Justin Morgan does streams and stuff like that. You know, we all just hop on and hang out and do cool nerd things. So check us all out. Who said, Jeremy, did you get the Tandy thing? Yes, Jeremy, I did get the Tandy thing. It is sitting in my email. I haven't dug into that yet. I've got a lot of stuff on my bench that I'm working on. So yes, thank you for sending that to me. I'm going to see if I'm going to actually take a look at that right now. Stand by. Where did you send me that email? Where did you send me that email? You sent me an email. It's buried here somewhere. I know I got it. It's here. It's here. Hello? It's in my email somewhere. I don't know. I'll find it. Other things coming up soon. My next video is going to be a kind of sort of collaboration with Javier Rivera. He broke something, and he sent it to me to fix it. And so we're going to fix that. Also, maybe want to put up some footage of my vacation because I got to go to the System Source Museum in Maryland, which is a friggin' awesome place, and I got basically the full tour. It's like a 3-hour tour. A 3-hour tour, so that'll be cool. So, Justin, I fixed a board live on stream last night. It looks ugly, but I think it's fixed. Yeah. I had damaged it live on stream Saturday. Yeah, those are always the fun ones when you catch something on fire live. So yeah, I think we're going to wrap it up for tonight. Thank you all for stopping by, hanging out. Thank you for supporting me over all of these years. And just, yeah, like I'm really bad at like doing the thing, doing these outros and all of that stuff. But again, thank you for stopping by. And if you ever need anything, remember to stop on by Joe's Computer Museum, hang out, watch a couple of videos, and 8 bits are all you need.